Hi guys, so my name is Paul and I'm going to talk about what I think a normal web developer should know about web security. Or an alternative, yet another OWASP talk. So before we begin, I am a normal web developer. I have a keen interest in security, but it's not my area of expertise. If there are any security experts in the room and you have any questions or suggestions, feel free to raise them at the end. Like I said, I am a normal web developer. I know enough about security to know that I know very little. And I know enough about security to be paranoid. And that's kind of what I hope people to take away from today. Kind of, they know a little bit more and a bit more paranoid. So we are going to use the OWASP top 10 to kind of go through the list. Hopefully you can read that in the red. So OWASP, if you're not familiar with OWASP, is an open web application security project. It's a not-for-profit charitable organization that focuses on the top 10 kind of security risks. They come out with a new list every couple of years. The most recent one is from 2017. Previously it was 2014, and before that 2010, I think. Generally the list remains something the same. Sometimes new ones are added, old ones are taken off. But it has a broad consensus of this is the kind of top 10 in order of web security risks. We're not going to have time to run through them all, so I'm going to run through roughly about 5 of them. Hopefully I have time to run through all of them, and we'll have questions at the end. So in my experience, I've found that many developers, the average developer, they might know some of these terms. They might know how they're actually implemented, but they might know the risks. Might actually be lucky enough to see like a pen test report to see what their application is, if it is vulnerable or not. But your average developer generally has only a vague understanding. So that's what I want to kind of jump into today, to actually show what these are, how they can be exploited, and the consequences, and how we can avoid them. Some of the demos later on, I tried to keep them as simple as possible, so there's no kind of external tools. They're all kind of very simple tools, just to show the basic concepts. But there is lots of tools freely available out there to kind of exploit web applications. So the first one people may be familiar with is injection, or SQL injection. Injection flaws such as SQL occur when untrusted data is sent to an interpreter as part of a command or a query. So a developer might be generating a SQL command, something similar to this. They're basically using string interpolation to build up a command. They're going to swap out the variables username and password for whatever the end user has entered. And although this is quite poor code, you'd be surprised how frequent code like this can be found in source control. So the developer, when he's developing it, obviously he's thinking of the happy path if someone enters Paul and secret as their username and password. The generated SQL will be like this. That's perfectly fine, it'll work. The person will be logged in or not, depending if the credentials are correct. However, they mightn't be thinking about a malicious user. So a malicious user might enter something like this as your username. So instead of entering just Paul, I've entered Paul and a single quote, and or 1 equals 1 and a double dash. And effectively what this means is our generated SQL command now looks like this. So the first word clause is now been closed, username equals Paul. Our injected command, or 1 equals 1, we know will always be true. And our double dash effectively means everything else afterwards will be considered a comment, will no longer be evaluated. So again, this is a very simple example, but it's very effective. You'd be surprised how many kind of old websites and some new websites are actually vulnerable to this kind of injection. What makes this particularly bad is the first user normally entered into the application is some sort of admin or super user. So if this works, then potentially you have gained high access to the application. So that's just one example of SQL injection. Another, I'm going to look at this Hack Yourself First website by Troy Hunt. So he's deliberately created a website that has around about 50 vulnerabilities. It's free, you can go and play, try and find all 50. It's one of the better ones. There's a number of different sites. It's one of the better ones because it is kind of more realistic. Some ones, they do silly things like hiding passwords and images. This is kind of more a realistic application. And we're going to look for our first SQL injection. So for the first one, I'm simply going to look for a page that has a query string and replace the parameter with, again, a single quote. And if I hit enter, immediately I can see that this site is vulnerable to SQL injection. So there's a number of different issues here, but the first one is SQL injection. Now I know that it is vulnerable to SQL injection. I'm going to replace that single quote with another SQL command. So union select on a system table to get all the table names within the database. And if it's successful, which it is, below the images you can see all the table names in this database. This is a bit of a silly example. There's better ways to kind of gain access and to get more information, but it's a very simple, very effective way to show what can be done. So now we have access, we have all the table names. There's nothing stopping me going and get all the column names, even all the databases on the server. And that's just reading information. You can obviously add, update, insert, do whatever. Or a particularly malicious user might go to the classic probably drop tables. They might drop tables, they might drop databases. They might install malware on the server, or not have access to anything. So for SQL injection, there's a number of different very simple things. Again, a lot of these are kind of very simple things you can kind of do to avoid it. First, and it comes up quite often, is don't trust user input. Just don't. You'll never know who's going to use your system. Perhaps you might think about using an ORM, kind of keeping all the SQL kind of stuff far away so it's kind of generate for you. Or if you are generating SQL, maybe use parameters. I know as developers, we often moan about end users, about how they always find a way to misuse an application or misuse their site. But I think developers kind of tend to fall into the same way. They can find ways to misuse a framework. So frameworks will help you, but there's still ways to get it wrong, and they introduce your own vulnerabilities, so you still need to be careful. We're going to jump ahead a wee bit in the list to number 6, security misconfiguration. You should consider using the principle of least privilege. There's no reason why I should have been able to list all the table names in the database. There's no reason why that user should have been able to maybe drop tables or databases. Again, as developers, we can be quite lazy. There's our ops guy in the front of the room. Quite lazy and just using the admin for SQL or for our SQL user. You shouldn't be. Number 2, broken authentication. So incorrectly implemented session management can allow attackers to compromise sessions and identities and keys and passwords. And again, we're going to look at a very, very simplistic way of stealing a session. Again, back to hack yourself first. I'm going to capture, this user is logged in. I'm going to just capture the request and simply copy the authentication cookie into an incognito browser. This is obviously very simple, but I think it shows how easy it is to potentially steal a session. Once I enter this in, and in the top, if I refresh the page, you should now see I'm now John, and I have all his privileges. This is probably not as far-fetched as you first imagine. You might be on the Wi-Fi in this network here today. Do you know if it really is the Queen's Wi-Fi? Do you know maybe it's not? Maybe someone's set up their own Wi-Fi, their own Raspberry Wi-Fi Pineapple. Do you know if people are listening on the Wi-Fi? Maybe the websites you're going to are not secure. People could be listening to the traffic and capturing session keys and things. So I think it's quite a powerful example of how to steal a session. So broken authentication is often weak session management. Again, you might get session keys in the URL or in cookies that are not protected. Sessions mightn't time out ever. Very simple things. Brute force. On the internet today, there's hundreds of millions of valid usernames and passwords that have been cracked from previous exploits. It's very simple to just try your website with all their usernames and passwords. And poor password policies, so this is a bit of a tough one. It's a bit of like a Goldilocks. You don't want it to be too hard, so people forget passwords. You don't want it to be too easy, so they use silly passwords. But there's some very simple things we can do. Some of the expiring sessions after a while, let them time out if they're not being used. You might log out an account after n attempts. If an IP address is constantly hitting your login page with multiple users and always failing, you might want to lock them out or maybe add some sort of CAPTCHA. You might think about using multi-factor authentication. So the whole concept of what you are, what you know, what you have, what you are, your username, what you know, your password, what you have is maybe some sort of token, authentication token. You might be proactive and check to see if credentials have been found in a breach. I know Troy has an API that you can use to query to see if an email address or a username has been found in a breach. If it has, you might be proactive, lock them out, and send them an email to say, please change your password. And you should be using HTTPS for all the things. There's no real argument now not to be using HTTPS for anything. All the old tired arguments of it being too expensive, or they're not free, they're too slow, well, I think now the speeds are negligible or even faster using HTTPS or TLS 1.2. Number 3, sensitive data exposure. This is one we've already seen. Many web applications and APIs do not properly protect sensitive data, such as end user, financial, or healthcare data. So we've already seen an example of this in our first SQL injection example, and the error page came up, and that gave away a lot of information. From that error page, we were able to see that it was vulnerable to SQL injection. It was using IIS, and we could even see what framework and things it were using. Some other examples might be that endpoints are not secured. So security through obscurity is simply not security. There's a couple of websites out there. Shodan, for example, is basically a Google search engine for vulnerable applications and systems. If you're ever bored, go on to take a look and you can see all the open webcams that have default passwords, and you can watch somebody at the other side of the world. It's kind of a bit terrifying. You might expose sensitive information and exception messages, what we've seen previously. Or you might send data over the wire with poor or no encryption. Again, back to TLS, you should be encrypting everything. Obviously, you should be restricting access to private APIs. Like we said, security through obscurity is not security. Everything should be restricted. Encrypt in transit, obviously TLS, SSL, but also you should maybe think about using HSTS. So with SSL, if the first request is made over HTTP, the server will usually redirect you to a HTTPS page. However, that very first request, if it's the first time you're on the site, that first request is still susceptible to man-in-the-middle attacks. So if someone is able to capture the first request, then there's nothing stopping them from redirecting you somewhere else. With HSTS, it's effectively a list you can sign up your domains for. That will be sent out to all modern browsers. And when the browser makes that first request, it will check this list to see if it's in it, and it'll automatically make your first request over HTTPS. So it's definitely one to investigate. It's also one to be careful of, because once you're on the list, it's very hard to get off the list if you make a mistake. Obviously, use up-to-date and strong standard algorithms. Things like triple days and all the old algorithms are kind of considered broken. You should be using more up-to-date algorithms. bcrypt, for example. And salt and hash passwords. So sometimes people salt and hash passwords, or they encrypt passwords, but they're not really sure why. So obviously, if a password, it should be hashed. It should be one way. There should be no way to get your original password back. And you should add a salt to a password. But often people mightn't understand why you add a salt to a password. So we can look at a very simple example. So I've been playing Zelda quite a lot recently. But so Zelda and Link both have the same password, secret. And it means when the password is hashed, the hashes are the same. So if someone was able to get access to their username and passwords, they'd be able to see that both Zelda and Link have the same password. They'll be able to use something called a rainbow table. So they can go on and you can download a list of all the well-known passwords. You can generate hashes for all the well-known passwords and a simple lookup to see which hash matches up with which password. And I think generally they have between like a 40 and 60% success rate. So it's very easy to kind of reverse a hash if you have a rainbow table. If you have a salt, the salt is simply appended to the end or the start of the password. And it means even though Zelda and Link have the same password, the resulting hash are completely different. So if someone was able to get access to this and they were able to generate rainbow tables, they would now have to generate these tables for each user rather than just one table for all users. So there's like an extra step of preventing people to find out the passwords. I think I've risen through this. Number 5, broken access control. So restrictions of what authenticated users are allowed to do are often not properly enforced, and attackers can exploit these flaws to access functionality or data. Examples of this can be something as simple as modifying parameters in the URL. If you have an ID in the URL, is it a sequential ID? Is there anything to stop me from going and changing a 1 to a 2 to see what I can get? Probably accessible backup files. Hopefully this is kind of a thing in the past, but it's probably more, it's probably not. If you go onto a production website and you take a copy of the config file, do you name it config.back? Well, if you do, that's now accessible via the internet, which we'll see in a few minutes. And path traversal. So number 2, publicly accessible backup files. If you go back to Troy's Hack Yourself First page, by default, already we know this is IIS server. By default, IIS will not serve up a web.config file. However, if you've taken a backup and just named it .back, .org, .wherever, it will quite happily serve it up. It wasn't on this site. If you've taken a backup of the whole website before you're making any changes, it'll quite happily serve up your zip file, and potentially someone will have access to all your configuration, all your settings, potentially your source code. So just be aware, like if you do have backups, make sure they're not accessible via the website. For path traversal, sometimes you see websites, instead of serving images directly, they might serve it through their own custom control. So here we're using a control called images, and they're serving up a profile image. What's stopping me from changing that to our web config? Again, by default, IIS will prevent it from serving the web config, but if you do it through a control like this, it'll quite happily serve up your configuration files. And there's also nothing stopping me from using path traversal to kind of go up and down folders until I find what I want or what I need. So for this, what we really shouldn't be doing is we shouldn't be using the profile name, the profile.jpg. So maybe using a lookup table, maybe have that, swap that out for an ID. Look that ID up in a table before we serve the file, rather than just using the file name. And the last one is cross-site scripting. This is my favorite one, cross-site scripting. So cross-site scripting occurs when an application includes untrusted data in a website without proper validation or escaping. And this might include reflected cross-site scripting. So maybe I'm inserting JavaScript in the URL and sending it in an email or sending it in a message. And also persistent cross-site scripting. Maybe I can add a comment to a page, and everybody who views that comment will get the infected script. So with cross-site scripting, there's some very dangerous things you can do. You can steal user sessions. You can steal users' cookie. Something very simple like that. Well, it's just an alert box, but we could steal it and send it somewhere. We can redirect the user to malicious sites, and we can inject our own script libraries, and this is where it kind of becomes fun and dangerous. So one example might be Beef, the browser exploitation framework. So this is available freely on GitHub. I was able to spin up an Ubuntu server and install this in less than half an hour. And this, once I'm able to inject my JavaScript, this is what I can do. So this is the server. This is the Beef server. I'm going to open up their own sample page, which has the infected JavaScript. If I go back to our server, you can see that a client has appeared. So now I can see everything about that client. I can see their OS, their browser, all the kind of click events and things they do in the browser, right down to, rather strangely, what graphics card I have. You see some of them. A lot of kind of scary information. I can use it as a proxy. I can redirect all my traffic through this user. And you can see a whole list of different exploits that potentially can be run on the server, on their browser. For example, I think I'll open up in a second. I can turn on the webcam. I can turn on the microphone. It does pop up like an Adobe alert box, but most people just click it and don't ignore it. Don't read it. I can modify the DOM. So if I go back to the page, and now I popped up a fake login for LastPass. Again, everything they do on this fake login is sent back to the server, and I can see everything. Or perhaps, if you're not familiar with, you can see that's what I was typing as I was typing it. Or if you're not familiar with LastPass, we can change it to a Google login screen. And again, everything I type there is sent back. The framework's quite clever. It doesn't just modify the page when someone's using it, because that'd be quite obvious. It kind of waits until they've tabbed away. And maybe when they tab back, they've forgotten what they were doing. And they just see a Gmail login page, and they'll just naturally type in username and password. So you can see cross-site scripting. Only allowing these whitelisted domains. So I'm allowing myself, whatever website I'm on, and Breen.dev, my personal website, and Google. And for images, something very similar. And there is a whole list of different policies. If I haven't explicitly set one, then default to the source. And what this will mean, if someone is able to inject a framework that is not on the whitelist, the browser will just refuse to load it. If you are upgrading from HTTP to HTTPS, and you don't want to go through and update all your links to use HTTPS links, you can tell the browser to upgrade all insecure links automatically, which is also very useful. And the one I find the most useful is a report URI. So if someone is able to inject something onto a page, the browser will block it, but it will also call your API endpoint, and it will notify you of what page and what has been injected, so you're able to go and investigate and remove it, and hopefully prevent the vulnerability. So we kind of ran through that very quickly. But the takeaway I hope most people get today is you're slightly more aware of what you may or may not know, but also kind of showing enough to be paranoid, slightly paranoid. There is a number of different things to kind of look up and see. There's the OWASP list, which provides a lot of tutorials, tools, and examples. There's Troy's Hack Yourself First website, which is fun just to go and see if you can find all the vulnerabilities. And there's a few other ones as well. I think that was me.
Thanks very much.
Yeah.